Our next lesson is called the Zero Product Property Day 2. So at the top, you're going to see two definitions. The first one is the definition of a quadratic equation. A quadratic equation is a polynomial with equation of degree 2. So that means we're dealing with x squared. B says standard form. So hopefully you remember standard form from previous lessons. The terms of the quadratic equation are collected in descending order of exponents and set equal to 0. So you want your exponents to be going down. The format should be ax squared plus bx plus c equals 0. Then the next statement is really the most important. The equation must be in standard form in order for you to solve it. So you have to take the time to put the equation set equal to 0 before you can factor it and solve for each piece. So we're going to work through several examples together. We're going to solve and show our work. So we want to start by simplifying the equation the same way we do when we were solving equations in previous times. If I see distributive property, I'm going to look for that first. If I see it, I'm going to simplify it. So I would get x squared minus 8x equals 2x minus 25. Now, usually at this point, you would look for variables on both sides since I don't see any like terms on the left or any like terms on the right that I should be combining. So I'm going to move that 2x by subtracting 2x. And I get x squared minus 10x equals negative 25. So I'm closer, but I need that to be equal to 0 in order to be able to factor it and complete the problem. So I'm going to have to add 25 to both sides, which will give me x squared minus 10x plus 25 equals 0. Now I finally have it in standard form because it's descending, and I also have it set equal to 0. So after we get it set equal to 0, our next step is to factor. So this is going to factor into two binomials, and we have to keep the set equal to 0. So I'm looking for the factor pairs of 25 that would add up to negative 10. So that would be negative 5 and negative 5. So x minus 5 and x minus 5. After you have factored, you're going to set each factor pair equal to 0. So x minus 5 equals 0 and x minus 5 equals 0. Now, since they are the same equation, you can just solve one of them. So I'll solve the one on the right by adding 5 to both sides and getting x equals 5. So that means my answer is x equals 5 with my set notation. Let's move on to number 2. We have 18x squared equals 30x. So I need to try to start to get this in standard form. I'm going to move the 30x so that it's on the other side with the x squareds. So I would have to subtract 30x from both sides to do that. I get 18x squared minus 30x equals 0. So I now have it in standard form. Now when I look at this one, first of all, I don't see that it's a trinomial, and that's okay. So I know I'm not going to be factoring it into necessarily two binomials. Always make sure you look for a GCF first when you're factoring. So if I always look for a GCF first, I have a GCF between 18 and 30. It is 6. And between x squared and x is x. So I'm going to factor out a GCF here. So 18x squared dividing out 6x would be 3x. And negative 30x divided by 6x would be negative 5. So I have factored my quadratic equation using the GCF. Now again, at this point, once it's factored, you're going to do your t time and set each factor equal to 0. And remember, this is all based on our zero product property that either one factor or the other one or both have to be equal to 0 in order for the equation to be equal to 0. So now that we've set each factor equal to 0, we'll solve each piece. I divide by 6 here to get x alone, so x is 0. On the other side, I would have to add 5. So 3x equals 5, and then I would have to divide by 3. So x equals 5/3. So when you write your answer, you can write x equals 0 and 5/3, Or you could write x equals 0 and 1 2/3, whichever form you like better. One thing you should not do, though, is use any repeating decimals. So we want to have nice decimals, and if we cannot, we have to write them in fraction form. All right, let's look at number 3. In number 3, we have 7r squared plus 14r equals 21. So we need to get this in standard form by setting it equal to 0. So we will subtract 21 from both sides. So we get 7r squared plus 14r minus 21 equals 0. Now that it's in standard form, we want to start factoring. So the first thing we look for is always GCF. I do see a GCF here. There's a GCF of 7. So I'm going to take that out and get r squared plus 2r minus 3. Remember, you're dividing that out. And now, resulting, we have a trinomial. So I need the factor pairs of -3 that are going to add up to a positive 2. So that would give us r plus 3 and r minus 1. So now, I technically have been calling it t time, but you need to split it at every single factor. So here we kind of have a double t because we have 3 factors that we have to set equal to 0. So the first one, we do 7 equals 0, then we do r plus 3 equals 0, and then we do r minus 1 equals 0. Now, when you get a situation like the one on the left, 7 equals 0, we know that's not true. So you're going to slash the equal sign and write reject. That doesn't make sense for our answer. In the middle, to get r by itself, I would subtract 3. And to the right, if I wanted r by itself, I would add 1 to both sides. So r equals 1. So now I know the answers are -3 and 1. Moving on to number 4, we have 2d squared plus 5d minus 12 equals 0. So here, I don't have to set it equal to 0. It's already in standard form. What we do have, though, is a more difficult factoring. When I try to take out a GCF first, there isn't one. So this is a trinomial with an a value that is not a 1. So we have learned several different strategies on how to factor these types of problems. If you need to, you can go back and watch any of those videos or go back in your notes to see the different strategies. You either have to guess and check or trial and error method, or you need to split the linear term where you multiply a times c, find the factor pairs of that number, pick the pair that adds up to the middle number, and then do that thing where you expand the trinomial into a 4-term polynomial and regroup in order to factor. So you have resources you can refer back to for that. When you do actually factor this, you get 2d minus 3 and d plus 4. So then we will t time. This is time when we take each factor and set it equal to 0. And then we will solve each equation. Here I'd have to add 3 first to get 2d equals 3, and then divide each side by 2 to get d equals 3 halves. On the other side, I'd have to subtract 4 to get d by itself, so d is -4. So we have d equals, we have -4 and then 3 halves. Or of course, you could write d equals -4 and 1 1/2 if you'd prefer. Okay, moving on to number 5. We have x plus 4 over -1 equals 4 over x. So this is the first one that we're actually going to be using a proportion type of setup. So we want to do a cross multiplication. So we're going to first take this binomial, x plus 4, and put it in parentheses. We want to make sure we remember that that was a binomial and they should be kept together. And now we are going to cross multiply because this is a proportion since we have 2 fractions equal to each other. So we have x times x plus 4 equals -1 times 4. Now, you can put the x times x plus 4 on either side. Same thing with the -1 and the 4, doesn't matter. So here, I see that I have distributive property first that I have to simplify. X squared plus 4x equals, and on the other side, I get -4. So now I want to start getting this in standard form, meaning I have to set it equal to 0. So I'm going to add 4 to both sides in order to do that. So I get x squared plus 4x plus 4 equals 0. Now I can step into my factoring. I check for GCF. I don't have one. This looks like a trinomial that I want to factor, so this is going to factor into 2 binomials. Don't forget that equals 0. I need the factor pairs of 4 that are going to add up to 4, so that should be 2 and 2. So x plus 2 and x plus 2. So now I'm going to t-time that. I've got x plus 2 equals 0 and x plus 2 equals 0. So again, there's no need to do both sides. They're the same equation. So you're going to subtract 2 from both sides and you get x equals negative 2. So x equals negative 2. Now for this one, we have to make an extra note about something special that's going on. You have a variable in the denominator. So it's possible that this could be a problem. So just keep in mind that this cannot equal 0. So thinking back to our other chapter when we had variables in the denominator, checks are really very important for questions like this because you want to make sure you're not getting something that's going to result in an extraneous solution. So if we actually verify number 5, we would have x plus 4 over negative 1 equals 4 over x. In x's spot would be the negative 2. So I'm going to do my substitution. And then I get negative 2 plus 4 is 2. 4 divided by negative 2 is negative 2. And then 2 divided by negative 1 is negative 2. So we ended up all right because we had no 0 in the bottom and everything checked out, no extraneous solutions. So just a quick note on the very bottom of this. Quadratic equations may have 1 or 2 solutions. So as we were solving them, you could see sometimes we got 1, sometimes we got 2. Now at this time, if there's a practice activity for you to complete from your teacher, you are all set with this video and you can go ahead and go complete your other practice. If your teacher would like to have you complete the practice within the notes, at this time I'd like you to pause the video, try the practice problems on your own, and then resume the video to go over the answers. Okay, now that you've had time to complete the practice, let's go over the answers. In number 1, it says factor completely. So looking for a GCF first, there is not one. So you're factoring a trinomial with an a value that's not a 1. So I decided to use the method of splitting the linear term. 3 times negative 10, the a times the c would be negative 30. I want the factor pair that adds up to a positive 1, so I chose 6 and negative 5. I then rewrote my trinomial as 4-term polynomial, 3d squared plus 6d minus 5d minus 10. I grouped the first 2 together and the last 2 together. Then I factored out the GCF in each of those. And then the common factor of d plus 2 jumped out, and I know it's 3d minus 5 times d plus 2. Now, all I did in number 2 was add equals 0 to now make it an equation, not an expression. And it's the same exact one from up top, so you can use your factoring that you already did. You're going to set it equal to 0, therefore setting each piece equal to 0. You should get d equals negative 2 and 5/3 or 1 and 2/3. Then in what ways are problems 1 and 2 similar, and what ways are they different? So I said the factors of number 1 are set equal to 0 in number 2. So obviously they share those factors using the zero product property. The main difference is that number 1 is an expression and number 2 is an equation. So that's where you have the equal 0 as part of it. And that concludes your lesson on the zero product property, day 2.